Motion is everywhere. From the moment we walk, even as we sleep, motion takes place physically as the earth revolves around the sun and biologically as your heart never skips a beat. This is precisely the reason why we study motion, and the word that best introduces motion in physics is kinematics. Kinematics is the study of motion without reference to forces. Motion can be one-dimensional, two, or three-dimensional. In this video, we will only focus on 1D and 2D kinematics. When dealing with motion of an object, we need terms that describe them, and that includes the following. Average speed refers to the total distance you travel divided by the total elapsed time to travel that distance. This is only valid when an object moves with constant speed, which means that the object in motion is not slowing down or speeding up. Also, average speed is different from instantaneous speed. Instantaneous speed refers to the speed at a given moment or instance. Velocity is another quantity, and it's just like speed except that it's a vector quantity, which means that it has both magnitude and direction. Lastly, the acceleration. Acceleration occurs when an object changes velocity. By now, you should recognize that delta v over delta t is the formula for average acceleration, and whenever instantaneous acceleration is in question, it becomes dv over dt, which is the slope at any point of a velocity versus time graph. Also, this is known as the derivative at that point. Same reasoning applies for instantaneous speed and velocity. Displacement, on the other hand, refers to the shortest distance an object has traveled, and it is the vector equivalent of distance because it has both magnitude and direction. When we put all the definitions together, we will come up with the following variables. V naught or V sub 0 is the initial velocity, V sub f is the final velocity, x sub f or x final minus x naught or x initial is the displacement, a is the acceleration, t is the time interval. And with the following variables, we will have our three most important kinematic equations. Note that these equations are only valid when the acceleration is constant. To solve problems involving kinematics, you can use the guess method. Step 1 is to illustrate the question and write all the given from the illustrated problem. Step 2 is to identify the unknown or the one being asked in the problem. Step 3 is to choose the best kinematic equation. Step 4 is to substitute all the known variables in the equation. And lastly, to solve the problem and do not forget the units. Let's have a sample problem. A Tesla car begins at rest and accelerates at a constant rate up to a velocity of 120 meters per second. If it takes 6 seconds for the car to accelerate from rest to 60 meters per second, A. How long does it take for the car to reach 120 meters per second? And how far does it travel in total? So let's first start with the first question, letter A. Let's identify the given and unknown. So we have 0 meters per second as the initial velocity. The final velocity is 120 meters per second. We are not given with this displacement, acceleration, and time because that 6 seconds is not the time for the entire trip of the Tesla car. So we only have two values in our given, but remember that we need three values to use our kinematics equation. Fortunately, there's enough information in the problem for us to solve the car's acceleration. So we have from 0 to 60 meters per second, the time is 6 seconds. And since the acceleration is constant, we can use that to solve for the acceleration for both equations. And the equation that we will use is A is equal to Vf minus V naught over T, which is when we substitute, we'll have 60 minus 0 over 6, which is equal to 10 meters per second squared. Now we will use the equation to solve for time, and that would be 120 over 10, which is 12 seconds. So our final answer for letter A, how long does it take for the car to reach 120 meters per second? It's 12 seconds. For letter B, how far does it travel in total? So we can use different kinematic equation, but for this example, we'll use this one. And substituting the values, we'll have 720 meters. So the car has traveled 720 meters in total. For pre-pole problem, same process can be used to solve it. The only difference is that among free-fall problems, the acceleration due to gravity is equal to 9.8 meters per second squared. Just be careful about choosing a positive direction and sticking to it. So let's have another problem. Elon is standing on a cliff 30 meters above the floor. He throws a watermelon vertically upward at a velocity of 3 meters per second. Neglecting air resistance, how long does it take until the watermelon hits the valley floor? So let's start with our given and unknown. So we're given with 3 meters per second as our initial velocity. We're not given with the final velocity. We're given with negative 30 meters per second as our displacement since we choose the starting point here or the reference point here as 0. So below 0, that would be negative 30. And the acceleration due to gravity is negative 9.8 meters per second squared since we use the up to be positive. And we're also not given with time. So remember that displacement is a vector quantity. Even though the watermelon goes up before coming back down, the displacement is simply equal to the height at which the melon ends its journey, which is 0 meters, minus the initial height. So 0 minus 30, you will have negative 30 because down is negative and displacement is negative 30 meters. So substituting it with our kinematic equation and by using the quadratic formula, we will have t equal to 2.8 seconds. So we can avoid using quadratic equations in all kinematic problems by solving it another way. So we can try to solve for the velocity when the watermelon hits the ground using the third kinematic equation I presented earlier. Then we just plug into the first kinematic equation, which is Vf equals to B naught plus AT, and that will give you the same answer. But this is another way of solving the problem. So the final answer would be 2.8 seconds. So that is 2.8 seconds. Not all objects move in straight line or 1D. Some objects move in 2 dimensions. And when an object moves in projectile, the most important rule is that the object's motion in 1 dimension does not affect its motion in another dimension. Here's the tip. If the problem is similar to this, a ball is shot at a velocity v from a cannon pointed at an angle theta above the horizontal. Always remember these rules, no matter what the problem looks like. The vertical component of the velocity v sub y is equal to v sine theta. The horizontal component of the velocity v sub x is equal to v cosine theta. The horizontal velocity is constant and the vertical acceleration g is directed downward. So let's have another sample problem. A ball is shot at a velocity 25 meters per second from a cannon pointed at an angle theta 30 degrees above the horizontal. How far does it travel before hitting the ground? So we use our guess method. Just write a given for horizontal and vertical motion. And we will have the following. So I use here negative 10 meters per second squared as the acceleration due to gravity to simplify everything. And remember, for the horizontal and vertical motion, the time is the same. So we first solve for the time using our kinematic equation. So we can use this formula. Substituting everything, we'll have 2.6 seconds. And using that t, we can solve for displacement in the horizontal chart. Using the same equation, we can have 57 meters, or you can just use this formula. R is equal to V squared sine 2 theta over G. That should give you the same answer. In summary, kinematics is a study of motion without reference to forces, and that motion can be one-dimensional or two-dimensional. Kinematic quantities can be used to describe the motion of an object. Kinematic equations can be used to solve kinematic problems. Now that you have learned how to solve kinematic problems, go back to Physics 51 LRC Canvas module and try the solved example problem entitled He who was not sinned cast the first rock with correct answer and step-by-step solution. Here is the answer key to the problem. This is lesson 1, kinematics in 1D and 2D. I'm Mike Angele Aloba, LRC peer tutor for math and physics.